Everything is in place for better solar systems. We have the best lasers, the best micro-optics, the best manufacturing processes based in roll-to-roll, even the best material based on 3-5 alloys to maximize the efficiency of transforming sun into energy. Let's bring all this industry together and learn what we can do for each other. We're going to get insights from the laser manufacturers, those picosecond UV lasers driving this market. Also, we're going to hear from the laser production machines, companies like 3D Micromac or Inolas, scanning systems, production inline metrology, energy management coatings, even the testing of the solar cells. Join us Friday, June 26 at 3 p.m. for an in-depth epic online meeting on solar energy systems, powered by the sun, inspired by my daughter. Thank you very much, everyone, for being with us today. Today is 3 p.m. and it's only 48 hours since I did the crazy thing that Carlos had in mind of chairing an online meeting for 24 hours. I'm still alive, full of energy, as you can see. Dick the man is seeing me there and he's smiling like always. I have my friend Darius from Poland. Of course, I have here Ralph. I have Markus from QCells, from Hanwha. Long time no see. You look fantastic. Let's get the ball rolling. Let's start. Today is Friday, and I promise you I put this clock here because we are going to finish on time. At 5:30, we all start the weekend. And we start by saying that I'm so happy that the meetings are getting such an interest from the industry. We only have actually only 8 to go, and I feel a little bit sad because this has been a truly amazing experience. We started on 1st of April, we're going to finish on the 15th of July, and I can already tell you that on Monday, we are announcing the topics for the online meetings after September. This is not going to stop. We started because of COVID-19, but we continue because of you, because of the support that we're getting from the industry. Such a strong support that is getting us now so close to 600 members. We're only a few members away. So if any of you are thinking whether they should support the association, of course you should. Just send me the form if you want more information about what to do for becoming a member of EPIC. All you have to do is send me an email, jose.pozo@epic.com, and make sure that your logo is included here and you are acknowledged as a new member of this association. We organize events, you all know that, but we also provide access to the network. So this is important for everyone in the YouTube channel or everyone in the room today. If you want to get in touch with any of the participants today, all you have to do is send me an email. I will give you the email address later. It's jose.pozo@epic.com. And also, if you are looking for raising capital, this is very important. We have a network of 80 investors, corporate investors and public investors. So if you need to raise capital, let us know. We'll help you with that. We'll help you finding people to cover your positions. Jobinphotonics.com is now the biggest website in photonics. And of course, you all know this. I don't have to repeat it. We give you market data. There's 17,000 market reports, view graphs, market data available for all the EPIC members. If you want to access any of these market reports from Thematis, from Joel, from Strategies Unlimited, from Penguel, let us know and we'll let you know how it works. But I think you all know. You all know, and it was so crazy. I just want to say that I got so many emails thanking me for this. I am trying to answer all of them. I'm doing my best, but I had to sleep after the 24 hours. I really had to take some hours to sleep, but I'm going to get back to the emails and thank all of you who gave me the congratulations. Also connect you. For all of you who asked to be connected to another person, I'll make all these introductions over the weekend. And now we start with solar. I mean, such an important topic for EPIC. I've been discussing with one of our speakers today, our opening speaker, Andreas Brand, on how important is solar for the EPIC community, mostly focused by lasers, by optics, and by material providers. We want to align all of you, and we want to push the solar industry at EPIC like crazy in the coming 2-3 years. And Andreas Brand is going to be one of our key people here. But I would like to acknowledge first the sponsors. And today, this event couldn't have been possible without the support of Morphotonics. In Veldhuizen, the Netherlands, if you are looking for a partner for the role-to-play production of micro-optics or microstructuring of any material, role-to-play, equipment suppliers, service supplier, and of course, prototyping, this is the person to go. Morphotonics is a key company in the ecosystem. Thank you for sponsoring this event today. And today we have a great agenda, but even greater is my co-host, Dr. Amairi-Pyka. How are you doing this beautiful afternoon?
Thank you so much, Jose. It's a very beautiful afternoon. You did a miracle 2 days ago. It was really great. And nobody
do I look tired? That's very important.
You don't even look tired. That's the thing that makes me crazy. It's really amazing what you did. But let me tell you about the meeting today. So we are speaking solar energy systems. And we will be having amazing speakers from the field. I already saw one of them. I think it's Andrew with the solar panel behind him in the screen. And I don't like to show this. I would like rather to show the parts of the market that we cover. We cover the whole supply chain for the field. And we will look at solar cell manufacturers. We'll look at solar panel manufacturers. We will look at the material suppliers and many more. Stay tuned. The meeting is very important today. But Jose, why some members of EPIC are missing from this
I never forget any of the beautiful 573 members of EPIC. If you don't see your logo here and you think it should be, this slide only represents the companies who register for this meeting. So if you want to participate in the upcoming meetings, just register online or send us an email and we'll register you manually. We want to make things easy for you. And now I would like to say hello to the YouTubers. This meeting is live streamed in YouTube. So for all you following in YouTube, if you want to get in touch with any of the participants today or any of the companies that Sana and me mentioned, all you have to do is send me an email, jose.pozo@epic-asoc.com. Send me an email and I'll make that introduction because I do love connecting the community. And as I said before, this meeting couldn't have been possible without the sponsor of Morphotonics, but also without the feedback that I got from a new EPIC star. So they have EPIC members and EPIC stars. And the first speaker today is an EPIC star. Andreas Brand has been from the very beginning a follower of the EPIC online meetings. We've been chatting, talking. I could really publish the log of our chats is actually goldmine. And he's been the one saying, we have to push the solar industry with EPIC because at Fraunhofer ISC, we do such an amazing technology. Andreas Brand, thank you very much for being with us today. For the first exceptionally 9 minutes, the rest of you have 6 minutes, but Andreas has 9. That's what it matters. That's what happens when you're an EPIC star. The floor is yours, and I'm looking at the time here. The floor is yours.
All right. I hope you can all hear me.
Loud and clear.
Do you see my slides?
Also crystal clear.
Excellent. Well, good day, ladies and gentlemen. I'm very honored to speak here today on behalf of the Fraunhofer ISE. And I'd like to start with the Fraunhofer Gesellschaft. We are about 28,000 at this moment, and there's more than 70 different institutes that do applied research across Germany. It's a very successful model. And Fraunhofer ISE was founded in 1981, and ISE actually stands for Institute for Solar Energy Research and or Solar Energy Systems, actually, which is kind of this, which is exactly the same what today's workshop's title is. So I could speak about any of these subjects, but I will try to do my best to stay within time and give you a good overview about what it is that we do, and then go a little bit deeper into laser processing for solar cells. So why is solar so important? Well, I think we all know why, because we need clean and sustainable energy, and this can provide it. I would like to start though with other technologies besides the photovoltaic device that we do research on. And there's a group that is specializing on coatings for windows, low E glazing, for instance, to keep the infrared radiation outside the building so they don't heat up too much. Then there's obviously thermal solar receivers. We do color PV modules that fit the kind of facade you want to do with it, or other more visually appealing applications. They also do vacuum insulating glazing and optically switchable glazing. All of that is done via large area sputtering devices. Then we have a group that specializes in the simulation of coherent optics and also the application of large area photolithography. So we can do these huge area photolithographic stamps, basically, that we then can use and apply to surface areas on a mass production scheme. These shapes basically get imprinted, and then we can realize all kinds of different surface morphology shapes that fulfill a certain photonic application. And I thought, okay, this the work of this group definitely also fits within our topic today. Then let's have a look at the PV market. I think Markus is probably going to show some of these as well. The PV market, as you all know, has exponentially risen through the time. And the biggest player today, even in installation, has become China, after Europe was, and also especially Germany with their feed-in tariffs, was leading this branch roughly 10 years ago. I'm not going to talk too much about thin film today, because thin film actually just makes up less than 10% of the overall market. This is always curious that many people think that thin film is bigger, because it actually was, but that time has passed a little bit, especially here in the past years. We also see that especially monocrystalline silicon wafer-based solar cells have now taken over the lead over the multicrystalline ones. What technology is in the market today? The older style back surface field solar cells are slowly but surely fading out, and PERC devices with a passivated rear side complementary to the front side, which is always or for a long time been passivated. You see this bluish dielectric coating for anti-reflection purposes on the front, but this new technology also has an actually a reflective mirror, a dielectric one on the rear side. I'm going to show something about that later. And this is basically taken over the market at this point. And then there's going to be some follow-up technologies. IBC has been there for a while, but we are especially interested in the heterojunction cells and the tandem systems that will provide a lot more performance in the future. This is always a very interesting curve because it basically shows the price decrease in the solar module market. And if you look at the logarithmic decline and especially look at the years that are depicted here, it is extremely interesting to see that over the course of 10 years, we have now decreased prices again, another 90%. So this technology is not only has become very cheap, but if you look at the cumulative model shipments, it is also quite well researched, and it is there to stay. There is no excuse to say today that solar is expensive anymore, because it actually is not. One thing to start my route to the laser processing, there's currently one laser processor already in this mass-produced PERC cells, and there is very likely going to be a second one, which is the laser doped selective emitter. As you see here, we predict, or VDMA predicts, that this will take over during the next decade as well. Specialized applications still yield higher pricings. Obviously, very interesting is here building integrated solar cells, vehicle integration, I'm going to show an example of, and the aerospace industry obviously is also dependent on solar cells to power their satellites or the space station. And these type of solar cells are obviously more expensive, and not so many have shipped yet, but they are also a lot more performant. So I wanted to give a quick overview, and I'm going to jump across this slide very quickly about the different or the main types of crystalline silicon solar cells, wafer-based ones that there are and will be very likely. The aluminum BSF cell is the classical one. The PERC cell, now being in the main device, has this rear side passivation layer that also acts as an infrared internal mirror. So you gain a little bit of current, and you also passivate a lot of the surface area to get a better electronic behavior. Then there's the tunnel oxide passivated contact cells that we have also developed at Fraunhofer ISE. We think those are going to take over a little bit of market share quite soon. Then there's heterojunction, which has been around for quite some time. And you might have heard that Meyer Burger is now considering or is not considering, has decided to start heterojunction solar cell production in Germany soon, instead of selling their tools anymore. So this is going to be the next German-based or European-based solar cell production, very likely. And IBC with interdigitated back contacts has been around for quite some time, but it's very process heavy to produce these. That's why they are quite expensive. Another trend that we see is that we're gonna definitely see some multi-junction solar cells, meaning that there's here a silicon solar cell and we stack another type of solar cell on top of it that can take better, has higher efficiency to utilize the solar spectrum. This is an example of a 3-5 based top cell system, which can yield up to 36% or 34% at the moment is our record, I think. But we are obviously trying to get the price down on these. But here also we have a very nice example of a photonic structure on the rear side. So why do we want the higher efficiency solar cells? Because we wouldn't want a car like that, but more like that. And the higher the efficiency of the solar cells, the more additional range, for instance, we could automatically get by the car self-charging if standing around at the sun. Another group that has something to do with photonics research deals with power by light, where we create specialized solar cells that are optimized for one wavelength. They can be irradiated with a laser by fiber or by free air lasers. And those have definitely applications for powering sensors that need to be insulated, for instance. So also very interesting application. Now, applications in photovoltaics for lasers, there have been many throughout the years, but many of them died off again because they got replaced by better techniques. But a lot of the applications have actually switched to ultra-fast laser processes, and that's kind of what I want to focus on, because ultra-fast laser processes have become a lot more affordable. The laser market basically undergoes its own learning curve, and it is has been quite steep as well. So many of these
from all
lasers,
these potential applications that you have there for ultrafast laser, what are the two that you would say they are the most important ones that we should focus this meeting on?
the scribing is still the most important one. Yeah. But also for there might be some cutting applications coming, and you can actually dope with these, but it's currently not considered. But you can achieve much higher dopants than with others. But I will give a good example.
We are running out of time, so maybe we can rush. You can give us an example, and then we can have some Q&A.
Yeah. Okay. So I'm going to give two short examples. The ultra-fast lasers have a smaller damage depth, and you need to use a UV as a wavelength because many of the typical PN junctions, for instance, are in that depth range. And but they also cause some kind of damage, which is an amorphization of the surface. And so I'm going to jump to that result. We have come up with a technology that prohibits this, so we can actually have a perfect, almost perfect damage-free crystal in combination with the ultra-fast laser process as well. We do that by temporal beam shaping. So if somebody has a question regarding that, I can mention it. I'd like to show one more example of a process that we're very proud of. We apply a very cheap aluminum foil to the rear side of the cells. We cut it off, and with that we can provide a very cheap electrode on the rear side. And I'd like to finish with a fast process that shows you that we're also embedding the highest end of scanning technology to make our processes fast, because that is what we need for this very price competitive market. So thanks for your time.
Thank you very much, Andreas.
I had too many slides anyways.
No, but you have to promise me, because we are going to organize soon a presence meeting on solar, and I want you to be the keynote opening speaker. You are the flag holder for the epic community in the solar industry. You are my champion. I'm really happy that that I met you. Really, really happy with that.
Thanks for the praise. I will keep the other slides in stock for then.
Good. And do you even have more than that? Okay, no, but you already know the drill here. So you know how the meeting works. It's about cooperations, collaborations, it's about starting working together. So the epic question, what can you do for them and what can they do for you?
Well, we have kind of hit a wall some time ago when it came to the machines actually applying the laser processes. A lot of the handling is not fast enough anymore. And precise machines, for instance, are usually built very heavily out of granite and very massive systems. And then they need to move quickly in order to get all these wafers underneath the laser scanner, for instance. So one area of research for us today is how to get these machines faster while maintaining or even improving on accuracy. So that is one field of collaboration that can deal with scanning systems manufacturers and also laser beam source suppliers, but also camera manufacturers, because all of these systems need very fast and also cameras that can do calculations on system, for instance. And what we can provide is basically we have the entire virtually integrated platform, not just for solar, but for other markets as well. We are expanding a lot of our technological know-how to other semiconductor applications, because we have developed them to the point where they are really affordable and really fast. So whoever is interested in semiconductor laser processing surely has a good partner in us, because we not only have the semiconductor experts in-house, but also the laser experts. So we can act as a good intermediary.
Today we have a lot of the companies who can help you with this. Many of them are going to give a presentation, so I am going to wait for them to answer the ultrafast laser, but you will love the presentation from JENOPTIK. But I'm going to ask you to meet some of my friends. And when you ask for cameras, we have a company in France. I love them. They make square cameras, very, very fast cameras. Thank you very much for joining today in this start of something big. Thank you, New Imaging Technologies, Martin, for joining today at this meeting. Did you see the presentation from Fraunhofer ISE? He's looking for cameras. It may be something that you can work together.
Yes, totally. Nice to meet you. Hello, Jose. So yes, New Imaging Technology is a SWIR sensor and camera manufacturer. So I have two questions for you. Is shortwave infrared technology interesting for you? And what do you mean about fast camera? Which frame rate are you looking for?
Well, if I could make a wish list, I would say 1,000 FPS with an FPGA on board that can obviously be programmed to do the major analysis on board, and then a fast interface to communicate directly with as little overhead as possible, for instance, to a scanning device, for instance, like a Gervo scanner.
Are you looking normally at infrared? Do you like the shortwave infrared, or do you need the
That
visible?
depends on the application. I think my friend Steffen Reinl is probably going to talk a little bit more about scanning later. Yeah. I think, well, we do share a common project, and yes, I know what they're up to. So you might talk a little bit about that.
Stefan, do you want to comment on that now?
Yeah, I will show some results or some stuff we are working on later in my presentation.
It is one of the pairings here that we have Fraunhofer ISE and JENOPTIK working together. We're going to make many more than that. This meeting would make no sense if we didn't have here the solar cell manufacturers, these companies who really need the entire supply chain. So I'm going to say hello to two of them. I'm going to say hello first to our colleagues from Azure Space. Daniel, thank you very much for joining this meeting. I know you asked to give a presentation and we couldn't fit you. I feel so bad with that. But what do you expect of a meeting like this? A meeting with people at decision-making level from companies in the photonic supply chain.
Hey, everybody. We are new to EPIC, so it's very interesting to see what's going on there. We work quite close together with some of them already there. So Fraunhofer is one of our major partner for R&D. I'm very interested to see what happens and what is possible.
We have to find things to do together. This meeting makes no sense if after the meeting I don't make some introductions for you to cooperate. And now I'm going to say hello. I'm going to say hola to my new friend, Teresa from Jinko Solar. Jinko Solar is the market leader worldwide. So we have the market leader worldwide, and we have Teresa who is looking for R&D cooperations with any company in the photonics and other technologies as well, supply chain. Teresa, thank you very much for joining the meeting today.
Hi, thank you for inviting me. That's my pleasure.
Could you highlight a couple of R&D lines that Jinko Solar is perhaps interested that we could maybe help you with?
Well, we are quite focused right now in bifacial technology, as well as in PERC, mono-PERC technology. So we have been also cooperating a lot with Fraunhofer Institute in the past, and I guess also recently I'm more focused on sales rather than in technical issues. But it could be very important for me and interesting to share the opinion of Fraunhofer related to the bifacial technology.
Fantastic. And now that we said hello to these two giants in the business, we go to the third giant. We go to Hanwha QCells. And Markus Fischer knows EPIC very, very, very well. He was already keynote speaker on one of our previous laser events. He knows what to expect, but we want to introduce you to even more companies. Markus, thank you very much for joining this meeting on this fantastic sunny afternoon. The floor and the attention of everyone is yours.
Yes, thank you very much for this kind introduction and for remembering my activities. So I don't know, does the screen now, is the screen visible?
Not yet. You have to go to the bottom of the screen. There is an arrow up, which is green, share, and then for the next.
Yeah, okay.
And then for the next 6 minutes, you see I'm pointing at the clock. Next 6 minutes, the floor is yours.
So
just share the screen.
I will try to stay within the 6 minutes. Yes, so thank you very much for introducing me. And yes, so Hanwha QCells is not anymore a pure cell manufacturer, but I will tell you here in this brief presentation something also about QCells. So Andreas, thank you very much for using something from ITRPV. So we have now the 11th edition, and so you just started with a learning curve that is always our figure 1 in the ITRPV. And here the results of this learning curve, really impressive learning during the past. So starting in here 1976, so with the first figure. So and having here the learning rate over the whole time frame from 1976 to 2019. We have a learning rate of 23.5%, and looking here on this period when the silicon shortage were overcome, so 40% learning rate. So the good news is the price learning continues. So we have currently prices below 23 US dollar cent per watt peak at last year's market of 130 gigawatt peak. And overall installation was 628 gigawatts. So, and in Vilnius, I presented something about laser technology in the CZ solar business. And here I summarized all the things, and it stopped in 2017 with the half cell. So 3D micromech is engaged there. So, and now here a big business in China is selective emitter, but anyhow, yeah. So each additional step increases the cost. So laser is a cheap application, but anyhow, it's an additional step, and this is a very important thing. So what's next for laser, we will see. So something about Hanwha QCells. So we have an integrated cell and module production capacity of 9 gigawatt, and production sites are all over the world for cell and module in China, Malaysia, and Korea. And in the US, we have a module manufacturing, and R&D is based in Germany. So about our products, so we are not focusing on record efficiencies, but on really good LCOE for our customers. And besides here, based on our experience, we have cells developed here we were the first that introduced this PERC technology, this aluminum oxide rear side passivation. So we have now completely switched to monosilicon. So this was also one finding that we see. And here the leading products we currently have. We have also bifacial products here available. And what we see here, so new wafer formats are introduced. So we provide here also M4 formats, and here also gapless technology with 0 gap. So QP Duo is our lead product. So and over the years, we continued the learning, and so we are approaching the practical single junction limit. So this is what we see. And here we currently reach 23% in the pilot production for monotype cells. And in modules, this corresponds to module efficiencies of above 20%. So now, what is the value chain QCells is covering? So we are coming from solar cells. We stepped into the solar panels. We provide solar power plants. You can buy systems, you can buy home solutions, and the new business is energy retail services. So this is what QCells is doing. So you please have a look also on the homepage of QCells to learn more. So we are not only a cell manufacturer, but we produce the cells for our own modules, and then we build also power plants for our customers. And now we have this energy retail business as downstream. So, and this brings me to the outlook also for our future. So this is what we have in this ITRPV summarized this year. So to have a look also what is the implementation of manufacturing technology. So we see here different scenarios in 2050. So for having here solar in the world, so powered fully solar powered world with about 69% generated by PV. So this would require an installation of about 63 terawatt peak. So today we have not yet reached the 1 terawatt. Something 620 gigawatt are installed. So, and what the good news are, so here we have the production or the market, the addressable market, and the addressable market today is with this 130 gigawatt chip. And we see here the future could be in this low scenario here, about 400 gigawatt market. So here, this medium scenario only power with 1.4 terawatt, and here this gigantic 4 terawatt annual production. So, and what we see is with the existing manufacturing technologies, we can serve this, but anyhow, the market will not be a constant growing, but it will grow, but with some volatility due to the very cost-sensitive activities, especially due to the competition in China. And good news, 100 gigawatt markets are ahead and can be served based on today's PV technologies, also for laser. That's very important. And have a look on ITRPV, how to see this. And QCells is one of the big players that support you for this future. So thank you very much. I think I was quite in time.
Excellent. Thank you so much for the very nice talk. I see a lot of people happy to hear it today. Let me first start by the epic question. So we heard now what you can do, and I am also impressed with the solar panel just behind you. What is that you are looking for, or let's say, what's your wish list? Like a list that we heard earlier from Fraunhofer.
So the wish list finally is that European manufacturers keep also alive in China manufacturing. So I think this is a very, very critical thing for tool manufacturers. It's also a reason why Meyer Burger stepped out now from the business. So it's very, very cost sensitive. And here, most of the value chain in CZ disappeared from Europe. Yeah, so buying wafers, buying crystallization. So even the polysilicon is about to to disappear. So, and this is quite critical. So I like here cooperating with also European manufacturers. So we find here, especially regarding the camera, so there is still a big market in China, and they serve Chinese market as well, and inspection systems, and yeah, so maybe new markets here for flashers, for so this now equipped with lasers. So these are important things that I'm looking forward. And I'm eager here as also with responsible for the development here in Germany, to work close with Europeans and not only with companies from outside. Yeah.
This is really nice to hear. I'm sure there will be a lot of introduction emails between Jose and other companies towards you. To do that, please write an email to Jose. His email is available for you. And let me see if we have a question from the audience. Jose, do you have one from your side?
Yeah, no, I don't have a question. I have friends, a lot of friends, and I have friends at Tampere University of Technology. Markus, when we met last time, you told me we're going to have the pilot line concept, so pilot production in Europe, making sure that all innovation is in the pilot production, and we transfer to Asia. And now I can see it's a reality, and I love it. How do we help you? So basically, I have the best epitaxy that you can think of. I had them at pilot production level. Is that right, Tampere? How are you doing, Mirsha? By the way, Mirsha, we cannot hear you, but you look fantastic with the beard. This COVID-19 beard that you have looks really great.
Can you see me? Can you hear me now?
Yes, we can.
Great, thanks.
So how can you help Markus?
Nice to see you all.
How can you help Markus? You have fantastic epitaxy, and they have a pilot line.
Yeah, I'm not sure. So I am actually, what we do on epitaxy is more on the emerging materials, like you know very well, the dialonitrides, tandem cells, moving as much as we can above the 3 junction, working now on 4 junction, 5 junctions, monolithic cells. It's not very clear yet how the synergy will be with Markus. There are clear synergies here with other partners, which I see. I'm happy to see IQE and then people at ICE and Azure. So not quite sure. So it depends more on them than on us. So we try to develop the next generation technology for PV.
We have here all the companies making customized epitaxy. Are they interested in having new epitaxy for
so the epitaxy is not for solar, already for the commodities in the solar PV mass market. So maybe for special applications, so where cost is not as crucial. So this could be a really good solution. So far here, as was mentioned at the beginning by Andreas here, so the thin film technology was thought to be the new technology for right applications. So finally, silicon and this single junction silicon is the workhorse of today's PV. And combining this with other technologies requires really mass production capable tools, and so this is not yet ready for applying this. So, but let's see. So if there are nice solutions for mass production applications, so then I'm very interested to see this.
Markus, I'm going to come to visit. Well, I will ask you if I can come to visit as soon as the whole thing is fully back to normal, visit the pilot line, and also would like to bring some of my friends.
Sure, you can see. Yeah, sure. And you will see that there is less fancy technology. It's for semiconductors, it's more or less technology of the 70s, and it's even screen printing, but at incredible performance and speed, and now this is the backbone of today's photovoltaics, and we will go further. So there is still headroom to the 24% and beyond with this tandem or whatever.
So Andreas Band is our flag holder on the R&D, and Markus Fischer is our flag holder for pilot production. Back to Pyka.
Thank you so much. Markus, stay with us because I heard your name in some technologies. You're very interested in laser manufacturing as well. And the next speaker, Andreas Oehler, is going to tell us about ultrafast application lab, ultrafast applications. Can you hear me?
Yes, I can hear you. Can you hear me?
Excellent. Yes, we are looking forward to hear the talk from Lumentum.
Perfect. Let me share my screen.
Yes, please.
So can you see the screen?
Yes, very good.
Okay, thank you. Yeah, my presentation will be way more generic, but I hope still that some of you might appreciate what they see and find it useful. Given the 6 minutes, I will limit myself to one specific application. In general, it's about advanced USP laser features for the photovoltaic manufacturing. Let me quickly introduce my company. Lumentum, we are like a 5,000 employee company. Our yearly revenue is about $1.6 billion US. We hold more than 1,900 patents, so we regard ourselves being a technology-driven company. Well, if you haven't ever heard of Lumentum, I can tell you you're not alone. We frequently hear that. We're not so well known in the general public, but at the same time, I can assure you that you use our products on a daily basis. And the best example is this online meeting, because Lumentum has a world leadership position in components for optical communication. So the traffic we're currently generating is very likely routed through many, many Lumentum components. Also, if you unlock your smartphone with your face, it is very likely that you do so using a Lumentum component in doing that. And if you don't do that and still use your fingerprint, I'm still very confident that you have some electronic device at home which contains components that were manufactured with a Lumentum laser. Okay, now to the topic. Oops, sorry. I want to talk about precise high-speed thin film removal using AccuTrig, which we call our trigger feature for ultra-fast lasers. So what we want to do is reduce the position jitter for individual laser dots, and we were approached by a customer with the following task. He wanted to produce dashed lines, dotted dashed lines, total length 100 millimeters, individual dash 600 microns, and individual dot spacing 100 microns. For feasibility tests in our labs, we did it at a moving spot velocity of 25 meters per second. At the customer side, it's now implemented with 40 meters per second scanning speed. We also had 2 sight lines for reference. So the issue the customer was facing was that he had unacceptable position jitter of individual dots of plus minus 50 microns on his workpiece. If you don't see immediately the jitter, you can definitely see it at the edge there. How the position really varies. Again, the spacing of individual dots is 100 microns. So what's the reason? The reason is that usually your scanner system is not synchronized to your laser. And the laser is an ultra short pulse laser, ultra fast laser, which is operating usually at a very precise fixed frequency. And this frequency is not synchronized. So your scanner system demands a pulse, but it usually doesn't know when the next pulse will be available. So that means you get a position jitter because your scanner demands something, but it will take some time before he gets the pulse. And in the next line, the situation changes, so you have a phase shift. And this results in this position jitter for the individual lines. Well, how can you resolve that? Well, you could synchronize your systems, but we came up with a different solution, which we call AccuTrig, which stands for accurate triggering. And we introduced that in 2016, and I think we were the first company in the ultra short pulse business to introduce a true USP laser triggering function. And what it means is you receive the pulse when your beam delivery demands them. So in this case here, right, it's here and here. And as a result, your pulses will line up, or you simply have the full control where you want to position your pulses, right? The feature we have implemented in our sources has a residual timing jitter of plus minus 12.5 nanoseconds. So if we scan at 25 meters per second, that gives a theoretical position jitter of plus minus 0.3 microns, which is usually sufficient for real-world applications when we talk about spot sizes of several microns to tens of microns. And what is extremely important, the energy stability remains at 2% or lower under fully arbitrary timing conditions. Earlier implementations had a triggering, but with significant energy changes, and this is not acceptable, especially not for thin film removal. Here's the result of a proof of concept. On the upper row, you see the process. At the left-hand side, you see the beginning of the line. On the right-hand side, you see the end of the lines. And this is without the Accutrick feature. And you see the position jitter of plus minus 50 microns. Here, as a guide for the eye, I added those red lines. And yet you clearly see how the individual pulses move back and forth or jitter in the upper row. If you look at the lower example, this is with the Accutrick feature. We could significantly reduce the position jitter. This particular substrate that we were using is just coated paper, so we could not accurately measure really how much the residual jitter was, but it was definitely below 5 microns. What you should also pay attention to is the absolute position. In the upper example, the distance to the guiding lines on the side is not equal at the beginning and the end of the line, while in the case of Accutrick, it's identical. It's very precise. So also to further look at the repeatability, what we did, we scanned the same lines over 3 times. And this is the result without Accutrick. So we reduce the power. So that's why it's a little more dim. And you see how the position smears out. If you would do more overscans, you would get a complete filled lines. In the case with Accutrick, you see that we always, for every overscan, we exactly hit the same position over and over again. So reproducibility is very high. And here's just a demonstration, but this is also, if you change your workpiece, you will exactly hit the position you want to hit. This has been done with one of our products. This is our latest product release, PicoBlade 3 system, with comparably high output power in the infrared up to 180 watts. In the UV, we have heard a lot of applications are more towards the UV. We offer 50 watts. Here it shows at 400 kilohertz, but we can scale that or move this point to the megahertz regime and get the 50 watts in the megahertz regime. We have demonstrated up to 6 megahertz. And it also exhibits this Accutrick feature. This works up to a trigger frequency of 2 megahertz, and we believe this is a very suitable frequency range and power range for high throughput applications. Well, now to the epic question, and I hope with that I can take it over the 6 minutes. What can you do for you? What can we do for you? What can you do for us? Maybe what can we do for you? We can support you in an early phase of your process development for the manufacturing, solving your manufacturing challenges. We have in-house laser apps lab, where we can support process development for laser processing and do feasibility studies. We actually also had a little project with Andreas, so he can confirm that we are quite flexible there. And of course, we have a very nice product. We offer very flexible ultra-short pulse laser sources with very high-end features. And when we develop special features on our lasers, we always try to target high throughput applications for industrial manufacturing. So what can you do for us? Actually, in this session, we don't really have the right audience for my first question. Currently, we're very interested in sophisticated spatial beam shaping solutions. For example, generating flat top with very high homogeneity, edge steepness, and also high efficiency. We're interested in multi-beam splitting with high energy uniformity between beamlets. And of course, reconfigurable solutions for beam shaping, SLM based. And of course, it's for us very important that these solutions are really easy to implement for industrial applications. And what the audience that is attending can really do for us. Tell us about your laser requirements for your specific applications. And we are happy to implement that into our product development roadmap for future products to even better serve this particular industry.
Thank you so much, Andreas. That was really, truly fantastic. I am having Lumentum at every meeting. So as you know, 48 hours ago, I had Brandon Collins as one of the final speakers of the 24 hours. And now you have me here like telling me about the ultrafast laser. This is truly, truly fantastic. And you answered the question very, very well. I want to see, because I know that Fraunhofer ISC uses your laser. I know that. They are very proud of that. That was actually the first thing he told me. So Andreas Brandt, I'm going to come back to you. So for me, the laser is a great laser. The Lumentum lasers are great lasers. But
we have done experiments with them, but we currently don't own one. But yeah, we are very familiar with them.
Okay, so 10% of the commission money, Andreas, is for me. And then we go for, the laser is only part of the solution. Andreas was asking for beam shaping. By the way, you don't know what you did. You're looking for flat tops and special line modulators. I'm going to introduce you to at least 50 companies, so be prepared to answer emails. But from the point of view of Fraunhofer ISC, what other cooperations, what other potential opportunities are there when you buy the laser from Lumentum?
The thing is, Lumentum still and held for quite some time the lead in repetition frequency for the ultra-fast pulse systems. I've seen a shift there. You no longer hold that crown, so to speak. There's some applications coming up where we're working with very high-speed polygon scanners, and we're actually looking into 50 megahertz and up of lasers in order to be able to feed these polygon systems that do a speed of 2 kilometers a second or something. So that is definitely something where many of your competitors have closed the gap or overtaken you, I think. And I see some applications, but I don't know how large the markets for these are. The other thing is the temporal beam shaping. We've done some experiments together with bursting technology. Yeah, and we are currently using a light conversion system that has gigahertz bursts. And we see some very interesting physical behavior in the gigahertz burst regime. So the megahertz burst is good for drilling and some other stuff, but the semiconductor interaction actually shows promising results in the gigahertz burst regime. So that would be another hint from my side at this point.
This is a very valuable input for us. Thank you very much, Andreas. Actually, with respect to the repetition rate, in principle, yes, we still offer products which run up to 8.2 megahertz, but there's no technological barrier why we could not increase that. I think what we are still leading in is that our seed oscillator is running at 82 megahertz, and that's about the highest. So we can easily open up the frequency. So far, we were barely approached by customers who were asking for higher repetition rates, or if so, they usually want to have that along with single pulse modulation at this frequency. And this is the more tricky point. And that is exactly where the market kicks in. If we see an opportunity, right, we are happy to work on that. Just to provide the frequency is actually, I can tell you, it's just a parameter in our software. I can immediately deliver you a 20 to 40 megahertz laser. To modulate that on a single pulse basis, that is a different story, and that requires more development and more adaptation. But if there's a market, we are very happy to serve that.
There is a company in Portugal, MW Technologies, that I think can help these two companies to work together because they do very well the pulse, the time pulse distribution. But I want to see, because I love connecting companies, and I think there's obviously business here between Lumentum and Fraunhofer ISC. If I'm not wrong, Steffen, you can add something to this, right?
Yes, correct. So Andreas, so if you told us that you are looking for beam shapers and beam splitting devices, so that's something we also have a whole division, micro-optic division, doing that. So if you want to share some specifications, then just let's share contact details and talk about it.
Thank you very much.
This is what we do here, no? People start getting to know each other and then they work together. That's what I like. And now what I want to know is to know a bit more about potential opportunities for our members. So I was really happy when I contacted the Becquerel Institute and I told them, could you actually give us something to work with on this particular market? And I'm going to ask, we're waiting for Becquerel Institute, has some problems with them. So I'm going to go to the next speaker. I'm going to go to Cardiff. I'm going to go to Wales. I'm going to open one of these pubs to get some beer. And I'm going to have a pint at my favorite city, next to my favorite castle, and next to my favorite company manufacturing wafers, 3-5 wafers for many markets. I am very active with them in the big cell sector. But today we are talking about solar, and we have Andrew Johnson with us. Andrew, thank you very much for being here all the way from beautiful Wales. The floor and the attention of everyone goes to the giant in the wafer production, goes to IQE.
Hi everybody. I hope you can hear me okay. It's a beautiful day here, so very nice to be with you all, and thanks for the invite. I'll just talk a little bit about IQE. For those, well, I'm assuming most people know who we are, but we're the global leader for compound semiconductor wafer manufacture. The largest outsource epi foundry globally, founded in 1988 and listed on the alternative investment market in London, market cap of about $1 billion and 600 staff worldwide. And as you can see, we have global locations. Our corporate headquarters, as Jose said, is in Cardiff in Wales, and we actually have 3 manufacturing sites, including a very large new manufacturing facility in the UK, but we also have 4 sites in the US and a couple of sites in Asia, one in Taiwan and one in Singapore. And we have, well, more than 100 reactors in total now, both MOCVD and MBE. As I say, we've just opened a new manufacturing facility in Newport in the UK, and we've added another 10 MOCVD tools to that fleet of capability. A bit like Andreas said for Lumentum, these technologies are all pervasive. IQE sells into a range of markets, particularly the mobile phone business, and anybody who has a smartphone, a bit like Andreas said for Lumentum, anybody who has a smartphone probably has some IQE material sat in their phone, either a power amplifier or possibly a material for lasers, etc. So the way we're positioned now is to provide leading edge materials technology. It's basically to enable customers, coupled with our decades of expertise growing these structures at very, very high volumes, to provide to become the premier material solutions partner. To answer the questions that were set by EPIC, what can we do for you? Obviously, all of the things I've just said, we can provide material in large and small volumes for a range of applications, including solar in this particular instance. What can you do for us? We're always looking at ways, and particularly new ways of being able to validate materials and structures that we grow. So it's always those sorts of applications, as well as obviously customers that we're looking for. So as I said, our core business is epitaxy. Without sharing any customer confidential information, there's some pictures I'm sure most people here will be very familiar with. So a conventional triple junction solar cell structure on a germanium substrate on the left, showing the 3 subcells, which is essentially a fairly complex stack of different materials, and obviously getting the composition and thickness and doping and everything of those in large volumes is what this business is all about, and that's what IQE does. And then everybody, I'm sure, is very well aware of the NREL best research cell efficiencies graph. And obviously these tandem cells sit at the very highest efficiency and always have for the last couple of decades or so. those materials are widely used, as we'll see in a second, and actually IQE has some of the data points on this graph is material that we have grown. Sorry. The one issue, you know, we talked about cost earlier, and we've seen the fantastic success that the silicon PV industry has made in the last decade or so. Even though these cells have the highest efficiency, the high cost of these structures has precluded mass adoption of these for terrestrial PV applications. And I don't see that being the case for a little while yet, at least. But there are applications. Basically, these technologies are the technology of choice for space power applications. And I note that that Azure Space are on the call, and they're the leading supplier of these cells for that application in Europe. And in particular, the high efficiency radiation hardness of these structures lends themselves specifically for that sort of application. But there are some emerging markets that we're seeing now. So the low Earth orbit mega constellations, and I've put a picture of a OneWeb satellite here. And you know, not only individual companies, but SpaceX and Amazon and all sorts of companies are interested in putting these constellations in orbit for next generation communication systems. And even today, I noticed that the UK government is reporting that they are going to put in place their own constellation and actually take a 20% stake in OneWeb, which is the parent company which had recently gone into bankruptcy and so is up for sale. The parent company of OneWeb satellites. So there's, you know, a large potential market emerging there. And then high altitude UAVs, HAPS, which is high altitude pseudo satellite. And I've used a picture here from BAE Systems in the UK. This is basically a carbon fiber unmanned electrically powered vehicle that operates at about 70,000 feet on a semi-permanent basis, and all of the surfaces on these vehicles are covered in multi-junction solar cells. I've used an image here of a nice flexible array of these sorts of cells from some colleagues at Microlink Devices in the US, and those basically offer lightweight, flexible PV with very high efficiency, which results in very much the highest specific power at over 3,000 watts per kilogram. I talked about terrestrial PV, and there's been a lot of effort in the last 10 years that's essentially failed to provide terrestrial power generation through concentrated PV, and that's not dead. And IQE still has an interest in that area. And I just wanted a couple of slides to talk about a Horizon 2020 project that has just recently started that we're involved in called Hyperion. And this is led by a Swiss company called Insolight. And I noticed that David from Insolight is on the call today. Just briefly, this is a 4-year project ending in 2023 and a 11 million euro grant. Sorry. And 16 partners, including IQE, solar installers, R&D centers, to increase the competitiveness of the EU PV manufacturing industry with innovative solutions. And the objective is to demonstrate a manufacturing production innovation at gigawatt size for pilot line. And specifically, Insolight's technology is fairly unique in that it uses a tracking system so that you can focus direct sunlight onto these multi-junction cells. But actually, rather than having a big 2-axis tracker, which has generally been one of the drawbacks for concentrated PV, this is all in a very compact form factor, which essentially looks like a standard flat panel that you have with silicon, and has integrated micro tracking. So you can see the red arrows in both directions here. The dots are meant to be the position of the multi-junction cells, and you can see that the lenses then focus onto the cell. And as the sun traverses across the sky, you can adjust the the optics to maximize the output. One of the key differentiators here is that Insolight are using a silicon PV backplane, so that any diffuse solar radiation will be captured as well, with the intention of going to about 30% module efficiency, that kind of level. And just some pictures here. You can see the cells at the top, and there's a project website that everybody can go and look at much more detail if they should choose. So that's pretty much it from me. Thank you very much. Thanks for the invite.
Thank you so much.
No problem.
Thank you so much for this very nice talk, Andrew. Let me ask you a question. What is the most challenging part for you for the material?
Well, in terms of the solar application, cost is probably the biggest. So finding ways of reducing manufacturing cost is always perhaps the biggest challenge. You know, in our wider business, it's all about, well, cost is always is a key driver, of course, and go into large volumes, and how you maintain control over costs in these big volumes is generally the challenge. But as I said, you know, what is IQE looking for from fora like these is, you know, understanding new ways of being able to validate materials characterization, device characterization, you know, to allow us to reduce waste, to be more efficient, and essentially ultimately lower cost.
Thank you so much. Actually, we have the chance to have a representative of ALOS here in the room. It will be really interesting to see a discussion regarding the material. Alexander, thank you for joining the meeting.
Sorry, you're breaking up a little bit there.
Sorry?
We can hear you.
Hello?
Yeah, you break at the end of your last sentence.
Okay, I said it will be very interesting to see the discussion between you two regarding the material and challenge of the material. Can you tell us a little about ALOS and what you think is challenging?
Yeah, we at ALOS, we work with gallium nitride on silicon. And one question I have for you, Andrew, is have you ever considered putting nitride into the multi-junction solar cells?
Yeah, that's a good question. Actually, I talked about that you know, world record research cell chart, and actually one of the things we've done is putting nitrogen into the 3.5 semiconductors, which actually allows you to manipulate the band gap of the structures and tune it better to the solar cell. And I know that Mercer's here from Tampere, and they're experts in that field also. I mean, you know, what I would say is, you know, lots of interest in shorter wavelength, you know, going slightly away from solar, but UV detectors and so forth, that IQE has a significant interest in.
I see. Okay, interesting. Yeah, out of curiosity, because we have on the electronics, power electronics and RF, and lately in micro LED. What is your view on those industries and your company?
We have significant effort in power electronics, in nitrides in particular, and I'd be very happy to put you in touch with the relevant people in that area. And I'd say that micro LEDs is also something that we have an interest in now.
Mm-hmm.
Alexander, you're looking for an R&D partner on any nitride-based material. Tampere University, there is no better MBE growth in Europe, in the world. You can quote me on this. There is no better MBE growth of gallium nitride material than the one they do in Tampere. So you two, Mirshagini and Alexander, you need to do something together. Back to Sana.
Thank you so much, Jose. If there is no other question, because I don't want to be fast on this topic, it's important. If there is no, then we will go to the next speaker. David, thank you for my invitation today from Insolight. David.
Yeah, hello.
We're looking forward to your talk.
Hello, David. It's the first ever presentation from Insolight. Welcome, welcome
Yes.
to your new family. Welcome
Community.
Insolight. You have 6 minutes. Look, I'm pointing at the clock, and I want to find partners. This company is very well known in the solar industry, but it's their first ever epic meeting. The floor and the attention of everyone is going to you. Is going to Insolight.
Thank you very much. So I think you can see my screen, correct? Okay. So we got a very brief introduction by Andrew. So you've heard a little bit about Insolight already. My name is David. I'm leading the industrialization at Insolight. So Insolight...
Can you switch to a slide share so we can see the slides full screen? Yeah, there you go. Perfect. Presentation mode. Yes, perfect.
Good. Sorry for that. So what we do, we have over the last couple of years validated and developed the technology of a concentrated photovoltaic panel with integrated micro tracking. So basically we have an array of lenses on where we focus the direct sunlight onto a highly efficient solar cell. Today we use gallium arsenide cells. And we track the sun with a simple X and Y movement, which allows us to keep a flat panel, the form factor of a flat panel. We're a relatively young company, so we're a startup from EPFL in Switzerland, Western Switzerland. And the company has been created about 4 years ago. Last 4 years have been used to validate the technology. So we work with multiple partners, amongst some others, the Fraunhofer Institute as well, who helped us validate the efficiency of our technology. And today, so we are at the stage where we plan for production and ramping up, which is where we have we are part of this Horizon 2020 project called Hyperion that Andrew mentioned before, which is a 10 million project to actually build a pilot assembly line of our product, or of let's say of one line of our product over the next couple of years. One of the advantages of our product, which is that it can be translucent, so all the diffuse light can go through, which for certain markets is very interesting. So we have shown and validated the 29% efficiency, which compared to other translucent modules is 4 to 5 times more efficient than what is out there. An interesting feature about our technology is that translucency can actually be regulated and can go up to 75% of translucency, of course, by reducing energy production. But it's something that can be programmed into the panel. So imagining this is very interesting for the use case of agrivoltaics, where you put those panels on farmland, on greenhouses, and depending on the crops you have, you want more or less light going to the crop and can actually be adjusted. We believe that there is a strong economic benefits, especially in the agrivoltaic case. The panel is, as mentioned before, a flat panel, so it's easy to mount. It's compatible to whatever conventional panels are mounted, so should be same. And we're targeted to give a 25 years reliability in the field, of course. So what are we looking for? So basically, as I mentioned before, we're a relatively small team. Our expertise is really in R&D, validating the technology, building up the processes. And we have a second part of our team, which is working on selling the panels, distributing them. We are not planning to build up production ourselves. So that's where my role in the company is, making sure we can produce our panels with the reliability we want, at the quality we need, and at the volumes we need to be competitive, which goes also with the price. So at this stage, we are really looking for partners to manufacture those panels, be it the assembly of the full panel, but also all the subcomponents from the cell, packaging of the cells, assembly of the backsheet, the optical layer, which is a critical part of our panel. And so we're looking for partners, contract manufacturers who can help us ramp up our production with the goal of in 2-3 years from now being able to produce 100,000 square meters per year, or even more. So that was my very short presentation. I'm happy if there is questions, or if people after the call can reach out to me. So thanks a lot.
Thank you very much. It was your first ever epic presentation. You were epic, right on time, and actually sharing challenges, which is what it's all about. We have questions in the room. The first one is coming from my friend Mirsha from Tampere. Mirsha, what's on your mind?
Yeah, great. So great to hear about your technology. And yes, I share what has been earlier said. The CPV. We started developing tandem cells for some years now with looking to CPV. Luckily, there is something else but CPV. Anyway, my question is related to how stuck you are to the current 3.5 tandem technology, and if you also have interest and room to explore more advanced tandem cells, talking about 4-junction and above. What we would be interested to tell to the system level.
So for sure, there is room to explore any type of cell. Basically, our core of our company is the optomechanical system, and we can put whatever cell we want in that system. So in the end, it's all about cost. I mean, what makes sense. But yeah, our system is compatible. Well, yeah.
And the expertise on panel assembly is coming from in a partnership, or is your expertise on cell assembly and
so we source. So what we do, we source the cells. We have, I mean, as you heard earlier, we work with IQ on the Horizon 2020 project. We actually also work with Azure Optics, who is also on the call. So we don't own the cell technology, we source the cells. We then work with partners to package them and assembly them. But basically these are our suppliers, if you want so. And we have tested and we are testing different cells. So there's a lot of interest from our side to test different types of technologies.
Okay, thank you.
Yeah. Thank you very much, David. For me, it is clear that you're looking. You're at the right door. By the way, you're looking for partners in the assembly. This is what we have a lot of them here, and I'm hoping to make introductions. But I'm looking to two of our companies here to understand a bit how to ramp up to volume production. One of them is my very good friend Dirk de Man here in the Netherlands. I'm coming to visit you in a couple of weeks. Thank you, Dirk, for being with us today. So AAE is one of the companies that we have in the network that is helping with the automation for manufacturing to certain companies. Dirk, did you see the presentation from David? They are looking for contract manufacturers to assemble their modules. How can you help their customers help them?
Yeah, that's a good question. As a contract manufacturer, we mainly manufacture machines that assemble. So in this way, we could do two things. Together with them, we could think about a machine that could assemble it, and then make a prototype machine, and after that, another machine, so they can use those machines in their own plant to assemble it. Or we can connect them to companies that know how to assemble, and then ramp up their production. So either as a partner, building the first machine for them for their own IP, or we could connect them to a company who's already experienced in this.
No, Dirk, don't worry. You make the machine, I make the connection. So I'm going to go now to my friend from QCells, to Markus. He has a pilot line, so this is the best way to put your machine to assemble Insolight. How does it work, Markus? So Insolight is looking for contract manufacturers to assemble their products into pilot production. If it's for the solar industry, is that something interesting for a pilot line like the one Hanwha QCells has?
I think here regarding the technology, it's quite sophisticated, and the question was about the cost and price target you mentioned here. It's very cost sensitive. So what is your target regarding cost per watt peak for this?
For
the panel?
It actually, I think it depends quite a bit on the market we're going in, but I'm probably not the best one to answer that. I actually
you can say it's very cost effective. I learned that it
Yeah,
works
yeah,
really
okay.
well.
Okay, good.
I think we. Yeah.
Target market. So you mentioned here some high transparency, yeah. So and nevertheless here some high efficiency. So what is your target market? Maybe for building integration or so. This could be a very interesting market, yeah. Very interesting
integration
niche.
Definitely is one we're looking at, but so the initial one where we are talking to preparing pilot installations is agrivoltaics. So it's to put on greenhouses ourselves. So this is where we plan to start, and where we at the moment have the biggest market traction, because it's a relatively, it's an emerging market, and yeah, so this is where we see we can go in with, let's say, the lower volume still, but of course on the long run, with the combination of adding standard silicon cells below ours to harvest the diffuse light, we still think that in the long run we can be competitive also for rooftop.
Fantastic. David, your first ever presentation, lots of potential connections. I want you here, David. We had to solve this out. But we continue with this fantastic program. I want to tell everyone, for those of you who don't know, Europe right now has a huge revolution on the manufacturing of micro-optics. In my life, I had never seen something so big since the gallium nitride LEDs already 20 years ago. We have the best micro-optics manufacturing in the world right now in Europe, on the roll-to-roll, on the roll-to-plate, in the low-cost replication. In the roll-to-plate, Morphotonics has the key, but also in the solar industry, they can make an impact. I'm going to go to beautiful Veldhuizen now, and I'm going to understand a little bit what the rest of the supply chain can do. So Morphotonics, a great company, can be even greater. The floor and the attention of everyone is for you, and you have 6 minutes.
Thank you, Jose, for this wonderful introduction. I hope you can all hear me well.
Loud and clear.
I'll start sharing my screen. So yes, thanks again for this introduction and this opportunity to talk about roll-to-plate nanoimprinting for solar energy applications. My name is Pim Veldhuizen. I'm a senior development engineer at Morphotonics, and I'd like to start with introducing the company. The only thing is that my slides started to hang. Okay, there they are. Okay, so Morphotonics is an original equipment manufacturer, and we supply equipment that make nano imprinting at large area and substrates. We are founded in 2014, so we are a little bit more than 6 years old. We are currently with 25 employees and growing rapidly. And our headquarters is in Veldhuizen. And the markets we address are display, lighting, and solar. And we work on many emerging applications. We have a big pilot line, or not even pilot line, an operational line, fully integrated roll-to-plate nano imprinting at the customer in Asia. And this is really working 24/7. And we are really proud to tell this. And currently in this year, we are shipping out several other machines that will go into production. At Morphotonics, we have basically 4 divisions or 4 focus areas, and our primary focus area is equipment. So as I told you, we are an equipment manufacturer. So on the bottom, on the top left, you see one of the production machines that is able to do the nano imprinting on the substrates. But in order for this machine to work, you need flexible stamps, and these flexible stamps contain the pattern, actually the inverse pattern, that's going to be transferred onto the substrates. We supply and manufacture these stamps as well. Another important aspect is the imprint material. So we design and supply UV imprint materials that can be used in the imprinting machines. And this we do at our subsidiary company, Morphotonics Material. And at last, we have also a competence center. And here we do a lot of testing and a small volume sampling for our customers. Now, the large area we are focusing on is I think, really interesting and quite unique. And with large area, I mean really
more than 1 square meter sized devices or substrates. And we can imprint on discrete substrates, but not only on glass panels, but also on flexible films. And these substrates do not need to be transparent, which is not trivial. We can also print on opaque substrates, and this makes it particularly interesting to imprint on solar modules, which are typically not transparent. We have a reusable flexible stamp that we employ, and this stamp can last usually over 1,000 imprint cycles. And the structures that we can print range from 500 micron down to 50 nanometers. So it's a very broad range. And the imprint speeds of up to 10 meter per minute ensure a high throughput. And we can work with high robust UV curable materials that are able to withstand outdoor conditions. And on the right, you see a schematic of how the imprint machine will work. So the large area that I told you about really enables imprinting textures on the inside or the outside of solar modules. And this can be done on traditional modules, but also on other types of modules. And in particular, bifacial solar panels are interesting, and I will share a little bit more about it in a minute. Other markets that we can address are smart windows and indoor PV for Internet of Things applications, applications for drones, satellites, and automotive. So I'd like to switch to a solution that we have developed ourselves together with some partners for bifacial solar energy. And bifacial solar energy is an interesting market because this is rapidly growing, this type of module. And it's actually a very efficient way of collecting energy because both sides of the module can collect the energy. And in some cases, it can produce 30% more energy output than a traditional solar panel. So what we can do is imprint a microtexture or a nanotexture. In this case, it's a microtexture on the exterior of the bifacial solar module. And this makes sure that there is light trapping and less reflection. And the light trapping ensures that the light does not exit the module anymore, but is absorbed more efficiently than if you have no coating or no texture. And on the bottom left, you can see an example of how the texture looks in 3D. And we are also, in order to cover the entire solar module, we need to scale up the texture. And there you can see an example of a scaled up texture, which contains stitch lines, which are almost invisible to the human eye. So we tested this application in R&D test panels, bifacial test panels. And here we can see a current gain when we apply the texture. We can apply the texture on the front of the module and also on the rear. And interestingly, if we apply the texture on both interfaces, so the front and the rear, the benefit adds up to about 5% of current gain. So this you can see in the center graph, and this is all measured at standard test conditions. But usually, solar modules are not operated at standard test conditions. In the field, they are also receiving light that is off angle. And here, a second benefit from our texture comes into play. And you can see that on the right, because in the right graph, you can see the incident angle modifier. And this shows that the imprinted glass is more efficient in transmitting or capturing light that is under a large angle. So these two benefits, they come together in the field, and they will really enhance the efficiency of the module. And this is currently being tested in a test location. So this is one of the applications that we have developed. And on the right, you can see another partnership that we have together with the Dutch company Mitter Solar. We have covered the surfaces of solar cars with the microtexture. And both of these solar cars that you can see on the right participated in the World Solar Challenge. And actually, one of the cars won the race. So we are really happy with that. So this is you could say a niche market, but we are really looking for partners that can bring us into the other markets as well. For example, the bifacial solar panels. So we're looking for partners to team up and develop the technology further and introduce it to the market. thank you for your attention.
Thank you so much for this very nice talk. You know how it goes with EPIC, right? You tell us what you can do, and you should also tell us what can the others do for you. What kind of collaborations are you looking for, and how can you involve the others in your work?
Sure. Yeah. So what we are a equipment manufacturer in essence. So we can we have designed and built equipment that is able to produce this textures on solar modules. And we are looking for experts in the field of solar energy in order to really introduce it to the market, because we are known in the solar market, or we know the players, but we are not really a solar energy player. So we are looking for solar module manufacturers, solar module glass manufacturers that are interested in this technology and are wanting to develop this further with us and to really introduce it to the market.
Let's start with a question from Fraunhofer ISV to you.
Hi, Pim. Thank you very much for this very nice talk about your technology. I was wondering two things. What is the durability until this clogs up with dirt? Have you tested that? How easy is it to clean, obviously, but does it stay clean? And the second one is, what's your cost of ownership structure look like? So what is the most expensive piece of this? Is this the consumables? Is it the stamps? Have you considered other techniques in order to embed this morphology?
Thank you for your question. So these are multiple questions at once. I'd like to address them one by one. So at first is about the durability, and this is of course a very important and relevant question that we also get a lot. The most honest answer is that we're currently still looking into this, but there has been some tests with our partners at the TNO in the Netherlands that have done some thermal cycling and the damp heat test, and the textures are well able to withstand that. Regarding the clogging up and actually the soiling of the texture, this is indeed a concern. It's hard to test this. Actually, the only viable way I think is to test this in the field, and as we are currently doing this, we are still gathering data. But one thing that we can do is adapt the surface of the coating. We can play with the surface free energy in order to make it either hydrophobic or hydrophilic, and I think we can reduce the soiling in this way. And the textures can be clean. They are quite durable, so you can rinse them with water and even rub them. So I would say that's well possible. And then your question about the cost of ownership. This really depends on the volume, of course, but in the end, the most of the cost will come into the consumables and the resin. So if you scale up, I think you should think about cost of ownership in the order of about €1 per square meter.
Okay.
Just to give you an impression.
Thank you.
Daniel from Azure Space, I would like to get back to you. Do you think there is a lot to be done with Morphotonics after hearing the talk?
Yeah, interesting to see that you've equipped the race cars with your technology. Actually, I've seen we usually equip the race cars with our solar cells, and when you applied your technology to the glass, actually it could improve efficiency, which is very good, essentially.
Please allow me to introduce you to another manufacturer, optics from Fluence. Darius, can you tell us how do you find the meeting so far? And can you introduce your company?
Yes, it's very interesting. Thank you very much. I learned a lot of things here, and thank you for letting me join the meeting. So what Fluence does, we do ultrafast lasers, and we focus on reliable technology based on fibers, and we do high power femtosecond lasers. And actually, if I can go back a little bit and ask the previous speaker from Insolight if he's still here, because I was actually interested if it's possible to steer with translucence. in the cells you were designing? Like actively control the translucence, or does it have to be done at the manufacturing level?
No, we are actively steering the translucency. Basically, it's very simple. We're just misaligning our system, if you want so. So that means that if you don't have a backplane, we can, the focal spots, we can move them away from the cells and they go through the panel. So it's an active system. You can do it 1 hour per day, 2 hours per day, half an hour per day, whenever you want. It's programmable.
Thank you, David. Jose, you want to introduce yourself, the next speaker?
First, I have to say 2 things. The first one is Cheers Darius. By the way, this is one of the key companies to watch in Europe, Fluence, on the ultra-fast laser segment. This is one of the coolest things I have seen in the last year. And I'm really amazed that you're here. You're looking to many, many different markets. And if anybody is interested about the upcoming stars in the business, Fluence, definitely. You will see. Ask me in a few years and you will see how I'm right. I want to introduce the next speaker because ORAFOL's presentation as a member of EPIC, first ever presentation as a member of EPIC. I went to see them. I visit everyone. No? So I went to see ORAFOL, and this is the picture they took of me. Look at my tie. Look at my tie in the picture. You see? Yeah. Fresnel optics are simply fascinating. And we have Fresnel optics today. We have ORAFOL with us. We can hear you. We can see you. Thank you for joining EPIC. Thank you for being here. Thank you for this picture. I show it to so many people. The floor and the attention of everyone is yours.
Okay, let me start. I'm Juergen Zosel from ORAFOL Fresnel Optics, Managing Director. And I'm here since a long time. We are working on microstructured optics. Did this with an American company since 1991, and since about 9 years we are part of ORAFOL in Oranienburg.
Juergen, do you have some slides for us to see?
Slide? You can't see?
No, not yet. You need to go to the share screen at the bottom of the Zoom window, the green arrow, press it, and then you can select which screen to show.
I don't know what happened now. Sorry.
It's okay. Don't worry. We'll repeat and it will work.
That's not good.
No, it's really okay. We will manage. So just go to the bottom of the screen. Just share screen.
Yep.
And then you can select which screen to show.
Happened here, and I lost this slide.
I'm sure we'll manage because I made everybody so excited about Fresnel optics. Now they really want to see their tie in 90 degrees.
So you can see my screen?
Not yet. So did you press share screen at the bottom of the Zoom window?
Oh. Okay, now I think it.
Let's see if we can manage.
Okay.
Not yet. So Juergen, why don't we do something? My team is gonna call you, and they're gonna arrange with you. And in the meantime, I'm gonna stay in the capital of optics in Europe. I'm gonna stay in Jena, and I go from ORAFOL to JENOPTIK, and I come back to ORAFOL. Jena is fantastic. It's such a beautiful city, but JENOPTIK makes great speed cameras in the tunnel to enter the city. So be careful, drive carefully in Jena. Thanks to JENOPTIK, the speed is very well controlled there. Stephen, thank you very much for being with us. The floor and the attention goes to your fantastic speed cameras, your fantastic scanning segment, and the great optics of Jena. The floor is yours.
Thank you very much. So you can hear me, yeah?
Yeah, we can hear you very well. We also can see you. The slides are coming as well. And they are here. Beautiful slides. The floor is yours.
Good, thank you very much. Let me introduce myself. So my name is Steffen, and I am with company JENOPTIK. And I would like to start just sharing an agenda with you. So I will just give you a general overview of JENOPTIK. First, just explain you the divisions we have. Then I would like to give you an overview of our core technologies within the JENOPTIK optical system division. Then I would like to show you some inside activities of an optical solution for laser material processing. In general, it is called JENWELD, and its potential application or use in PV industry. And then I will end with a summary. So JENOPTIK is divided in 3 divisions, plus 1 division for mechatronic solutions, which is called Vincorion. Light and optics, which is the first division, is focusing on key technologies based on photonics. I will tell you some more on the next 2 slides. Then light and production is focusing on manufacturing and process automation, including laser processes like laser cutting and laser welding. And they do also systems for metrology applications. And then, as Jose already mentioned, so the light and safety division, they are offering systems for traffic safety, we call it, and like cameras and also tolling systems. So what are we doing within the light and optics division? We develop and manufacture different components used in different markets. One key application for sure is within the laser material processing market. And so we do precision components in optics and micro-optics, tailored and customized optical components. Then we do we have an own subsidiary doing beam shapers and beam splitters, refractive and diffractive optical elements produced in Jena, and we have also a division in the US. Then we do spherical lenses and spherical lenses for different kind of applications, starting from the raw material, doing all the lens shaping, polishing, all the technologies are in-house. Then we do coating technologies, so we do anti-reflection coating, then reflective coatings for different kind of wavelengths, from deep UV and to NIR wavelengths. Then we do beam splitters for IR wavelengths, long pass filters, short pass filters, and stuff like that. Then we manufacture also components and assemblies like if theta lenses, for example. We have a lot of series products there. Then beam expanders from manual to motorized. So especially the motorized beam expander is a device that can be integrated into machines and can control the collimated beam diameter of a laser source just by using an industrial interface like a Profibus or EtherCAT interface. Then we do infrared cameras, modules for temperature measurement, and even diode laser modules. And starting from the epitaxy, we do laser bars, single emitter units up to several hundred watts of output power on a passive heat sink. That's something we do in Berlin. So as you can see, we produce many different key components, also used for laser material processing industry. So we thought the next logical and consequent step for us was to use this deep knowledge and combine it to a higher integrated OEM device for laser material processing. and we call that JENWELD, and which stands for JENOPTIK Vision Enhanced Laser Tool. Yeah, so the JENWELD is an optical platform with powerful software, and combining this software with capabilities for fast laser beam deflection and integration into machines for laser processing machines. So I would like to give you a short insight into this functionality, just based on a wafer processing. I will show you in the next slides. So what you see here is the graphical user interface for the JENWELD software. So the system is able not only to take a high resolution picture through the optic in the optical axis, but you can also take a coaxial image of the whole working area with this optical processing head. This can cover, for example, the whole size of a wafer of 160 by 160 millimeter, for instance. And with this large image taken through the laser processing head, you are able to do different things. For example, you can define easily the position of your laser beam just by drawing a line on the screen where the laser should hit the part. And this can be done all over the working area of the optical head. And you see at the right side of this slide, underneath this red line, there's a laser scribe. So the idea is what you see is what you get. So draw or define your laser pattern on the workpiece, and the laser will hit exactly where you draw this line. The software is also providing measuring functionalities. So you can measure, for example, the solar wafer, the line pitch, or the line width on the wafer. And you can set limit values for the dimension measured and do some statistics and analysis, which is shown here on this last slide of my presentation. So as a summary, no, this is a slide, yeah, with showing you the statistics. So we did here, we measured here the pitch of around about 150 lines and analyzed the distribution of the taken measures. So this is an idea how to use this optical laser processing head for, in example, the wafer processing. Yeah, as a conclusion, I want to summarize that we are constantly working on higher integrated optical solutions here at JENOPTIK. One first implementations will be this JENWELD product, which will further improve into direction of high throughput applications for photovoltaic industry. And this we do also within an official funding project, which is running at the moment. So the idea is to yeah, take this technology of camera vision-based optical system into a fast scanner to increase the throughput for especially this kind of industries like photovoltaic.
Wow, Stephen, this is really impressive. Wow. So you just draw the line and that's it? Oh, yes. My God.
Or you can also load, let's say, a DXF pattern into the software and move it over your workpiece. And we have also alignment functionalities inside the optics, where we can recognize fiducial marks and stuff like that.
Between of course, I'm chatting while I'm seeing the presentation. Andreas is telling me there was already a prototype at Laser World Photonics Munich before, so it's a pity that I missed it. I really want to play with that. As soon as I have a chance, I'm coming to play with the prototype. Is it right now the demonstrator? Is it active in Jena, or do we have it in Freiburg, or in both places?
Both.
Okay, so I will come and play with it. Epic question for you, Steffen. Answer right. Epic question. What can you do for them? What can they do for you?
So what I would like to, discuss is, so you see here, that's a new product for us. So we are really looking for partnering with cell manufacturers and share experiences in the manufacturing, share some numbers, share some technologies, and talk about how we can collaborate in this area of using the laser with solar cells. And we can, as you see, we are a technology company and combining our technologies into an OEM device. And that's what we want to offer to the market, also to the.
Let me introduce, because I make a lot of friends talking to so many people. I don't know if I will ever stop talking again. I would like to say hello to our epic friend Enrico. Enrico, thank you very much for joining this meeting. We have a lot of technologies here. You are one of these key photovoltaic consultants who know the market very well. What can you say to my friends today?
I have one interesting question regarding the micromorph. I see that you made the position outside the modules. Have you tried to put inside in the module? The module have the window, the glass, the front glass have also one inside surface that is in connection with the encapsulant. So maybe in that manner you can decrease the problem of soiling and increase the possibility to increase the efficiency. Are you following me?
So is the question?
My connection is a bit.
Is this a question for
I also didn't really get the question. I think the question is for Morphotonics, right?
Yes, it's for Morphotonics.
Yes.
And you make the position on the outside of the module. Have you made the inside surface of the module where there is the encapsulant?
Yes,
so you avoid the problem of the soiling.
Well, it's an interesting idea. Unfortunately, the optics work in this way that it's much harder to get light trapping if you put the coating or the texture inside of the module, because you need optical contrast for it to work. And in this case, the encapsulant will have similar optical properties as the texture. So it is something that could be done, but it's more challenging than putting it outside. On the other hand, inside the module, you don't have any soiling. So yes, that's a good point.
Thank you, Enrico, for joining. Thank you for that great question. Are there any further questions or comments for Steffen? That way, I am so impressed with what you do. Really quite impressive.
I have one.
Yes, Andreas.
Hey, Andreas.
Hi. Many thanks for the great presentation and the great stuff that you present. I am wondering whether we should tell people that one of the ideas also behind it is that a system like that can be self-aligning.
Yeah, that was also my thought, but it's if we look in the future, this is really the idea that the system is self-aligning the laser beam on the surface, and that's what we are working on. So that's for sure one goal we want to achieve within the next 1 or 2 years. Yes. And this in combination with a high dynamic scanner, that would be the fantastic tool for the solar industry.
You know the goal that I want to achieve? I want to have this demonstrator working at QCells at the pilot line, and then go and visit with the two of you and then take a picture, the three of us with Markus. Thank you very much, Stephen. Out
Let's
of this
do so.
wall. It's hard to impress me, and today you have impressed me. I actually want to go and draw the line myself. That was really out of this world.
No
Thank
problem.
you.
Even I can do it.
we go to the next presentation. Markus, what do you think of it? Do you think we can put this demonstrator in Hanwha QCells spiral line?
Yeah, we should review a little bit, and nevertheless you can exchange here the presentation, and then we can discuss. Yeah, sure. Would be interesting.
No commission for me. You see, I do this for free. And we move to the next presentation. We go again to the capital of optics in Jena. We go to ORAFOL, and we're going to talk about Fresnel optics. Please have a look at my tie for those who missed in the previous presentation. Fresnel optics really rule. And Juergen, the floor and the attention of everyone. Now they're all very intrigued. The attention of everyone goes to you.
Okay, I'm now back. And I think I did a small mistake. I did put the wrong button. And so I lost the communication.
No, it was all a trick. I wanted everybody to be like very intrigued to what you're going to say. So it was all planned.
So I'm the managing director of ORAFOL Fresnel Optics in Apolda, which is close to Jena.
But give us the screen, the slides. Share the slides. We cannot wait anymore. Share the slides.
Share the slides, yeah.
Yeah. Okay, let's do the following. Why don't I share them from my computer? Let me do it from my computer, and then you can just tell me next slide, and then it will be perhaps. Oh no, you're doing it well. Yes, thank you very much. The floor is yours.
Okay, so yeah, we are close to Jena, and we have been a company who is working on microstructures since about 1972. We did work with American company Reflexite, and since 2011 we are working together, or we are part of ORAFOL in Oranienburg, and in this area we did work with a lot of polymer microstructures, and about 13 to 14 years ago we did start with the Fraunhofer Institute in Freiburg to start to develop the first optics for CPV. And I think I'm today not the first speaker for CPV, maybe the third or the fourth one. We delivered about 13 to 14 years ago the first array with 2x3 lenses, start to develop. I think I don't have to explain too much about CPV, how it works. We have heard a lot about the cells. Maybe I have to go a little bit back to the optics, which are very important for these CPV optics, because with these optics, we have a good chance to concentrate the sunlight to a very small solar cell, a high concentration cell. We did start at this point with a triple junction cell, and these triple junction cells, we had good partners who did cooperate with us. Finally, we did start about 10 years ago with about 30 partners or customers who are working in the market of CPV, who would like to install complete modules worldwide. And therefore, we developed a lot of different optics because there is no standard in the CPV market. Every customer has his own design, his own decision. Some customers are working from the very beginning with pretty small optics in the range of maybe 50 by 50 millimeters square. Other customers, or the customer with the largest optics was an American customer. He did work in a range of 330 by 330 millimeters, which was a very large array. If you look on the right picture, which is on the downside, you can see here 3 by 7 lenses, and these are approximately 1 by 2 meters for the complete array, what you can see here. So, and the goal, what we found was at the end to generate a module with the efficiency in the minimum of 30%. I think if we look on the top picture, where we see a single lens with a single cell, it's pretty easy. Finally, you have to see, if you look on the right side on the top, with a very large array with a lot of modules, then you finally have to take care that every lens and every cell is optimized from center to focus the light in a range of a factor of 1000 from the surface of the Fresnel structure to the very, very small solar cell. And this was a big challenge for everybody to do this, because everybody should know that a solar cell with a CPV is not focused on a standard module. You every time have to move this module in the right angle to the sunlight in 2 axes, and all these processes have to be done very, very precise, finally to have from the morning to the evening the best focus from the light to the very, very small cell. So therefore we had to develop very good conditions for the complete module. This means extremely good conditions for the glass. So we combined our microstructure with a silicon layer to glass. This means the glass was very stable, and this structure was mounted on the glass, and the structure was very, very helpful to have at the final end a very high performance of this module. We did start to produce, for example, modules in the range of up to square meters, like you have seen on the right side. But today, all modules are much smaller, maybe in the range of approximately 1 square meter, because every customer did understand that, for example, the movement in the glass, the extension, is very, very sensitive, and so you could lose the concentration from this very big lens to the very small cell. So a lot of challenges, and we did a lot of developments, and finally we have been, I would say, the market leader for the silicon and glass technology for this product. We developed here in our house the complete production capacity. We developed on the right side, you see a production line for SOG products. This was our complete own development. And we not just developed this product, we also built up the complete production line. Today we have still automated production line with a capacity of 40 megawatt here in Apolda available, which we could use, but maybe at the next 1 or 2 slides you can see why we can't use it today. This production line is today just limited to about 1 square meter, because the 2 square meter is not really an option for any customer today. What we did together is also, we did a lot of developments together with the Fraunhofer Institute on the lens, the concentration of the light for the very sensible cell. And so we did a lot of measurements, how to focus it, how to optimize the structure. We found out that we have to reduce, for example, the draft of our Fresnel lens, because a draft of a Fresnel lens is regular in the range of about 3 degrees. Just to produce these lenses, or to be able to produce the tooling tree, we did spend a lot of time and development to reduce this draft, for example, from 3 degrees to 1 degree, just to increase the efficiency of the module. we found out that we have to optimize the dimension of the structure to have the depths or the facet spacing of this structure not too large to get finally a very stable structure, because this lens has to work in the morning, and if the temperatures are not very low, it has to work over the whole day when the temperatures does increase. So it's a very challenge to have no difference or not too much difference between the focus of the lens and the real spot which we have from our cell. We also did develop a lot with our partner in the glass industry to have the right glass, because we had to use a AR-coated glass, which is adapted not just for the visible range of a lens. It also has to be work in the UV and in the infrared range, because this is the very special width of.
And this AR coating, you develop yourself in at ORAFOL?
But we work together with the Fraunhofer Institute and a glass partner to have a special coating, which we could use over the full range.
Okay, so basically, with collaboration, you can really enable almost any coating that can be deposited on top of Fresnel optics in the large volume, and the whole production is there. Why don't, as we are running out of time, why don't we go to the epic question? The epic question: what can they do for you? What can you do for them? Let's do collaborations. Let's do business.
Yeah, the problem is we did spend a lot of time together with our partner, but finally we haven't been able to use this product, which will show the next slide, because this market is very critical. And so you have not today different partners or users or suppliers available.
Okay, let's go to the next slide. Let's see what.
Yeah. And if you see here on this slide, you see what we have done during the last, or in the range of 2011 to 2014. We did work on at first on very large production areas. So we did support our partner Soitec, who built up in San Diego a very large company to produce these modules, and they built up a complete big company, and a part of the company was the area where we did work.
I have been, for those of you who don't know, I have been there. I have seen the manufacturing. It is out of this world, and I really admire companies who always manage to adapt to what the market does. The company was fully focused on the solar, and then you had to reshape the company towards satisfying other business. Today, you have here all your potential solar partners, suppliers, customers. Let's do business with them. Give them a potential room for cooperation that you can do business after the meeting.
Yeah, and the big problem is the equipment you can see here was done for 200 megawatts. The good thing was that the most cost of this build up did take Soitec. We have just a partner with a lower part of money which we had to spend on this, and about 1 or 1.5 years after we did build it up, they did lose completely this CPV market.
So today, I think Ralph has a question on that. Let's talk about applications on Fresnel. Ralph, do you have a question?
Hello, Jose. Thanks very much. Yeah, I'm one of the few that works in this in pretty much the same area. So now that you have all these installations at Zosel, hello, then are you thinking of other products to fill that void? Are there competitive products so that the SOG technology would make larger inroads into the photonics business?
Photonics business is very hard. Maybe you look at this. I can show you here concentrated photovoltaic.
But the question is clear. What is the main application today of Fresnel optics?
Yeah,
that's what Ralph was asking. What is the big one, the big money maker?
Okay.
The main application of Fresnel optics today is very wide structure to use our polymer optics, from PMMA, polycarbonate, or whatever. And what we did after we lost this market, if you look in the picture on the left side, you can see here in 2011, 2013, 14,
you have to adapt the company to another market. I'm sorry, Juergen, but we are out of time, and we have to make sure that you find business because you pay me for making you business. So the next presentation is really a potential partner for you. And remember that in 1.5 weeks, we have an epic meeting, online technology meeting on polymer optics. But now I want to find a potential partner for you, and that's JOANNEUM Research. I'm gonna go to one of my favorite cities in Europe, Graz in Austria, and to one of my favorite people in EPIC, my very good friend. Thank you for being with us today. The floor and the attention of everyone is yours.
Yes, hi. Jose, do you hear me?
Paul, I hear you clearly. I saw your slides clearly. Let's do business today.
Well, very good. So thanks for the nice introduction. Thanks for coming back from a more lighting-oriented application and research to a solar cell application. So we are a research institute in Austria, and I quickly are going through a quick overview. So the institute is called Surface Technologies and Photonics, and the short name is Materials. So you will see that also the materials questions are very important for us. The institute is not so big. We have 100 employees in different research groups. So we are doing hybrid organic electronics and nanostructural patterning. We are doing a lot of light and optical technologies, and essentially the technologies that I want to present to you today are located more or less in these two research groups. Then we are doing a little bit laser and plasma processing, thin film technologies. We have a group on sensors and functional printing, printed electronics, maybe also interesting for solar cell industries, and a new group on smart connected lighting, where we want to add sensor solutions to the lighting business. So in many talks today, sometimes a typical problem of solar cell modules has already been mentioned. There is optical loss in standard PV modules, let it be by cell reflections or by reflections on the glass or by void space which is not covered by active modules. And for that reason, you want to have solutions where you redirect your light in a little bit better onto the active area of the solar cells. So for that, we have done in the past some solutions which are maybe also known to you. So we can use, for example, femtosecond lasers, short pulse lasers, to burn more or less small structures into the EVA layer directly above those bus bars to redirect the light around these bus bars. Or we have some total internal reflection processes where we can again redirect light from the bus bars or from voids to other active areas. So this has been demonstrated with certain laser structures. We chose ellipsoidal laser structures, for example, and we achieved quite good results in efficiency enhancement on a module level. So another option, which I want to go into more detail, is nano imprint films. So we are not going to plastic optics. We are specialized in thin films and flexible films, and we are doing nano imprinting, a little bit similar to the technology that Morphotonics has introduced, but we are doing that on a roll-to-roll basis, so the roll-to-roll UV nano imprint lithography. And with that, for example, you can try to get some solutions like foils with deflection areas, which are in the micrometer range, to deflect light from the void parts to the active solar cells. the question of Mr. Zoni was also, why can't I do that within the glass plate? And I could say, yes, we can do that. Of course, you have to take care of refractive index differences, but solutions like that are also trying to get some air gaps maybe in between those structures, which help you to have a better change of refractive indexes. So these are typical applications, and what is our specialty on that is on the one hand, of course, the laser processing, but on the other hand, we have established a pilot line for roll-to-roll UV nanoimprint lithography, and we are using that for different types of micro-optics, which can be used in many applications. One of these applications, of course, also photovoltaics. And we are starting usually with optical simulation. Here we add maybe also freeform design to the different possibilities of optical things. Here you see, for example, a freeform Fresnel lens, which has freeform surfaces, but cut in a very small, in a very thin shape into a Fresnel principle. So when we have the design, we are going to a mastering process, which is in our case, most of the time a maskless grayscale laser lithography. And we do this on 6-inch, more details a little bit later. So with this maskless grayscale process, we can do a very good and very accurate mastering, which we transfer on higher areas with a so-called step and repeat process. This step and repeat process is a semiconductor process for replicating semiconductor structures onto UV resins, usually in an 8-inch wafer size. But we have built a machine which is doing that to produce shims for roll-to-roll imprinting. So for shims, you need a rectangular size of these step and repeat stamps, and then you can print them on a roll. And when you get your optics then onto a continuous process, which can run at quite high speeds, up to 10 or 20 meters per minute. One of our specialties is that we manage to get this replication in a seamless way on polymer shims. So at least within the accuracy of, let's say, few micrometers, this is even optically hardly visible. Another specialty is our in-house developed grayscale lithography process. So in contrast to commercial grayscale lithography devices, we can do different optics with a feature size down to 200 nanometers, an aspect ratio of yeah, let's say 4:1, it's the other way around. And we have a maximum structure height of 60 micrometers that we can achieve with such a with our home-built device, and this serves well for most of the applications that we are targeting in the photovoltaics and in the optics market. So finally, another very interesting thing that we did in the past, also Mr. Brandt from ISE mentioned colored solar cells. So sometimes you need for old red roofs, you need some coloring of the blue solar cells that they don't look so ugly blue. And here we tried out some silver nanoparticles, so plasmonic colors, which have the idea to have a very low absorption and a very dedicated absorption, like interference filters and so on, with a power loss that is very acceptable in the range, although you have to color these things. Okay, so a short overview on what we did on the technology. And what is maybe interesting for several of our customers and colleagues is that we are part of different European projects which supply also for small and medium companies, but also for larger companies, some specific funding opportunities for research activities. So for example, if you want to do smaller projects with us in the photonics region, we can apply for an ActFast project, which we are partner of the ActFast consortium. Also, there are new pilot lines and open innovation testbeds coming up next year. So also Morphotonics, and we are part of the Fabulous ICT pilot line, where we try to get freeform micro structures into the industry. So you can come to us, do small projects, usually below 100,000 euros, and these are completely funded or at least partially funded by the European Union. The chance to get these projects at the moment are not so bad. ActFast is running at the moment, and for Flex Function to Sustain and for Fabulous pilot lines, next year will be a good time to look for opportunities in this respect. That's it from my side, and I'm looking very much forward to your questions.
Thank you so much, Paul, for this very nice talk and for mentioning the pilot line. Actually, Fabulous is a partner in the Fabulous, EPIC is a partner of the Fabulous pilot line. And if you want to know more about this pilot line for freeform micro-optics, you can reach out to us. We will also hear more about lithography in the next Friday on the 3rd of July on the EPIC Online Technology Meeting on Lithography Technologies. Let me see if we have any questions in the room. Otherwise, let me ask you the EPIC question. You're an EPIC member, you know that. What kind of collaborations are you looking for, or what can you do for them, and what can they do for you? So we heard the part, what can you do for them? And we want to know now, what can they do for you?
Well, you know, we are a research and development institute that is doing research services for the industry. And of course, we need always live problems from industry that we can deal with. And also, it's very important to see, especially in the photovoltaics region, where the journey is going on, because we also have to adapt our technologies a little bit to these requirements from the industry.
Thank you so much, Paul. The next talk is going to be by Professor from the University of Parma, Professor Stefano. Thank you for joining the meeting. We are really looking forward to hear your talk today. We are very happy that you are here. And I want to hear first, how do you find the meeting? And
thank you. No, the meeting is very nice. It's very beautiful to see so many companies in one shot.
That's what EPIC does, yeah?
Yeah. Okay, let me...
Please start sharing your screen. Yes. You can go to presentation mode and you will be all ears.
Okay. Okay, thank you again for the presentation. I would like to make a very simple presentation, just describing a little bit the activity, one of the activities that we are making now about deposition and laser scribing of thin-film solar cells. I am from the Department of Engineering and Architecture of Parma University, and I'm working now on this project together with the Institute of Material and Electronics and Magnetism of the National Research Council. And the activity we are doing is mainly related to thin-film solar cells. Okay, someone of the previous speaker already has presented this graph. I don't want to spend time anymore to this. I just want to show that if you have a look at the green curves related to thin film efficiency, you can see that the value are reaching more or less the same value of silicon cells. And actually, between all possible solar thin films, probably CIGS is the material that can provide the highest conversion. With the advantages, as you know, of course, that the absorbing layer is about 100 times smaller than the standard silicon cell. And this, of course, allow you to work with flexible substrate for building integration and so on. So what we are doing now is working on the technique that is called low temperature pulse electron deposition technique that probably you know. I'm sure all of you know this technique. Actually, it is based on a beam of electron that is launched into the surface of the substrate that you want to develop, to growth. And it works in a way that it is really easy and cheap to do. I mean, the low deposition technique allows you to work on flexible polymeric transparent substrate. It works with temperatures that are, of course, as the name says, not too high, something like 280 Celsius degrees. The vacuum, of course, you have to work in vacuum, but not so high vacuum. You don't need to equip your lab with very sophisticated equipment and so on. And this is just some results, some images of what we can do. This is same images of the cells, and of course the behavior of the quantum efficiency and the voltage current characteristic. But without entering into the detail, at the moment we have achieved 70% efficiency, but we really believe that it's possible to increase by optimizing the parameter of the process. And of course, the other point related to this is the laser scribing. I don't need to explain you what is laser scribing. You have to scribe the back contact, the front contact, of course, the active layer in order to define the path of the current generated by the active layer. And we are doing this using laser, of course. We don't do any mechanical scribing anymore. And in doing this, of course, we have to we have been equipped with different kind of lasers, so we can work in the infrared, in the green, of course, with nano-pico, and if you need for some specific applications, also femtosecond pulses in different range of power and repetition rate and so on. The main idea, of course, is that we need to define a beam quality, a very high beam quality, in order to obtain very nice scribing, whatever the condition we are working. More or less, these are the activity we are doing now specifically. If I can waste one more minute just to tell you, just to consider the epic question, what can you do for us? For example, we were talking about beam shaper, and this is probably one very interesting topic that we would like to discuss in detail, maybe to investigate a little bit what we can do, because it's really a very important topic for us describing. And what can we offer? Actually, I think that the main point that we can offer is the flexibility of the university lab. We have a big campus in Parma with different groups working on PV, from modeling to laser scribing, material deposition, different materials, characterization of the cells, and so on. So actually, we have also experience in FP7, H2020 projects. So we have also led the project in PV. So we have the flexibility and the experience to provide some interesting contribution if someone of you wants to investigate it. I think that's all, and thank you for your attention.
Thank you very much. It was a great day, and you also even answered the epic question. We have lots and lots of collaborations here. It was your first ever epic event, and I'm gonna visit Parma as soon as you put University of Parma here, because I miss you over here. Thank you very much. It was a great meeting. I'm gonna get the two stars of the show today to give me the final remarks. The first one, Fraunhofer ISE, Andreas Brand. What do you think of the meeting today, and what is the next to come from EPIC on the solar industry?
I was a bit overwhelmed with the scope of the topic, because there's so much one could talk about that it was a bit of a shame for me to have to stretch it out so far, because I think now knowing the crowd, they might have been more interested in going to a deeper level on the wide fields of laser applications. That being said, it's definitely fun to see things from other places, because we still do most projects within Germany. And we are looking forward in the future to expand our efforts to the European scale, at least.
This is just the beginning, Andreas. We are going to work so much together. I take so many notes in all the meetings, and this meeting was great because of the amount of business opportunities. So I summarize here some of the ones that I see that's the low-hanging fruit. The first one, of course, in the laser process, Lumentum has very, very clear demands on the flat top, multi-beam, SLM-like programmable beam shapes. I want to ask all my beam shaping friends in EPIC, let's talk Lumentum, because we can do a lot of business here. Scanning solutions. There was a clear partnership there between JENOPTIK, Fraunhofer, I see they work together. I want now for them to work together with QCells and actually put that prototype in pilot production there. The other one is the inspection. It was clear from Fraunhofer ISE, from Andreas, that there is more need for cameras, for high-end cameras, to do the inspection from the visible to the infrared. Insolight gave a great presentation. They are looking for partners for assembly of their solutions. So any of the packaging companies who have in EPIC, and we have a lot, let's bother David because we can do business with him. High-end Fresnel optics, that's the question of the event. Is there still a market for European companies, especially for ORAFOL? The technology of ORAFOL, I put there my picture with the tie, sorry for that. I just look great with that Fresnel optic in front of me. I also love the chance that we have on new materials, and especially multi-contact solar cells. There's a lot of R&D room there, and we can actually collaborate a lot with Hanwha, QCells, and also from Jirko on that. On the manufacturing, we are amazed by the technology of JOANNEUM on the roll-to-roll, by the technology of Morphotonics in the roll-to-plate, even the coloring of the solar cells. I love that, from the silver nanoparticles that they use in JOANNEUM for the coloring. I want to finish with that message. Pilot production is available at Hanwha QCells, and they are looking for partners, and I'm always looking for friends. It's 5:31. Sorry for that extra minute. Have a fantastic weekend. You rock, and I love you. EPIC loves you. Sana loves you. Take care. Bye-bye.
Oh, thank you very much.
Nice weekend. Bye-bye.
Oh, bye.
5:31. I'm so sorry.
Thank
I
you.
would like to finish on time, but yes, we did it. It was a great meeting. Thank you very much, everyone. I hope you
Thank
enjoyed.
you.
I
Bye.
really enjoyed myself. Thank you.
Bye-bye.
Cheers.
Bye-bye.
Bye. Have a nice weekend. It's really hot outside. I hope you have a swim somewhere. You go to the sea or to the lake. Grazie mille, Enrico. Piacere. It was great to have you here. Paul, again, the star, everyone. Kevin, thank you for joining.
Thank you.
Take good care.
Bye-bye. Great weekend.
Bye. See you. Take care.